Here's a philosophical anomaly. Shouldn't you be outside touching grass and talking to real people? No, of course not. We just pick up the phone and talk to them through something like Discord or Snapchat. But how is information able to be transmitted at such a fast rate that people across the planet can send each other messages in fractions of a second?
This can be attributed to radio waves. So what exactly are radio waves? How do they apply to our lives? How do they differ from other type of waves? You've probably all heard of the term. However, most of us are unaware of the sheer influence it has in helping modern society function. Before we explore applications, we need to understand some key terms. Think of a typical sine wave. The wave repeats itself in the same pattern over and over again, and one pattern or wavelength typically looks like this. There are crests and throws, which show the amplitude, which is the maximum displacement of a point moving up and down throughout the wave. We can also measure the distance between successive crests or throws, which is defined as the wavelength. With the wavelength, we can determine frequency. Frequency is how many of these patterns occur every second. Radio waves are actually part of a larger group of waves called the electromagnetic spectrum, and each class of wave is typically separated by frequency, with radio waves being in the lower end of the spectrum, followed by visible light and gamma rays.
Radio waves, like all types of EMR, are made up of photons, which are tiny packets of energy that travel at the speed of light. Thus, all EMR travels at the speed of light. And light travels very fast, much faster than when my dad left. Meaning that radio waves can be transmitted across the world extremely fast. So why do we only use radio waves for communication?
Remember that radio waves have the lowest frequency out of any waves. If all EMR travels at the same speed, then the radio waves must have longer cycles or bigger wavelengths than the other EMR. Here's an analogy. Imagine radio waves as a human, visible light as a fly, and gamma rays as a molecule in the air. Imagine it starts to rain very hard. The human can walk through the rain without any problem. The molecule can also pass through the rain as raindrops, as they are much larger than the molecule. However, the fly is just slightly larger than the raindrop, and thus gaps between raindrops will not allow the fly to pass through. Here the rain represents a wall or obstacle that can block visible light, but lets through gamma and radio rays.
Well then, why don't we use gamma rays for communication? Well, radiation poisoning says otherwise. There's a reason why our atmosphere filters out almost all high frequency/energy gamma, because it will destroy your cells as well as cause genetic mutilation. So radio waves are the best way of transmitting data which can pass through solid objects and not turn you into Mike Wazowski. However, it's important to note that radio waves can't pass through all objects. Going back to the analogy, the raindrops represent specific particles that make up the obstacle. However, instead of it raining water, it rained T-34 tanks. Then the human could not pass through, similar to how radio waves have a hard time traversing conductive material, such as an iron wall.
Now let's take a look at how we use radio waves to do whatever humans do. Generally, it helps communication devices transmit data like FM and AM radio, television, mobile phones, wireless computers, and many other devices. In modern society, we have Wi-Fi which transmits data as radio waves into wireless routers that decode this data and put it onto the internet and towards our devices like our phones. As we've established before, radio waves have the lowest frequency on the electromagnetic spectrum, which allows it to pass through many solid objects such as dirt, stone, and brick, and isn't absorbed or reflected back. However, to a certain degree, it may interfere with the Wi-Fi connection. For Wi-Fi, there are frequency bands, which are a range of frequencies that transmit this data into radio waves. There's 5 GHz, which is generally faster and more effective in a close proximity than 2.4 GHz, which has a lower frequency that's less prone to Wi-Fi interference. Each frequency band can be broken down into Wi-Fi channels, which are specific frequency ranges, usually 20 to 80 MHz, between the upper and lower limits, that can be used to reduce this network interference. There are many different frequencies of radio waves passing through you right now, and it forms a complex yet effective network of interconnection.
There's also the radar, which sends out radio waves where we detect its reflections, much like echolocation, except instead of finding flying insects, it can do more human-like things, like detecting storms or oil deposits underground. Astronomical objects in our solar system also produce radio waves as a result of their ever-changing magnetic field. With modern technology, humans have managed to make gigantic radio telescopes that can help us learn about the composition and movement of planets, comets, gas, and dust clouds.
All in all, despite the complexity behind the concept of radio waves, the use of them and their properties is the very basis of keeping modern society function.
Thanks for watching, and make sure to check out our next video, how to use radio waves to dox your neighbor's IP address.